Hiya, so I'm going to do the Sunita example now as a separate vid, and that kind of gets us to consolidation questions, doesn't it? Right, so we've got a letter to post on the way to college. The post box is 500 metres east of our house, and the college is 3,000 metres to the west. Right, so let's put a line. Here's Sunita's house. Here's the post box. So it's 500 metres east of the house. The college is 3,000 metres to the west. So my college is there. Right. So we cycle at a steady speed of 10 metres per second and then take 10 seconds there. So we've done this 10 metres per second. Then we've had 10 seconds break, and then so it's essentially 10 to, yeah. It takes 10 seconds at the post box to find the letter and post it. Right. So taking east as being the positive, so that's good. So that's like a minus, isn't it, going back that way? Find Sunita's average speed. Right. So Sunita's average speed. Okay. Now I need to know how long it'll take Sunita to get from the house. So I need to know the time from the house to the post office. So if I do, so what have I got then? So speed is distance over time. And I want the time, so it's distance over speed. So my time is 500 metres over 10. It takes 50 seconds. Is that right? It's not far. 50 seconds to get there. She must be going on a fast bike. And then, if I look at the time to get from the house to college, ooh, excuse me. It takes me 350 seconds. Right then, so that's all the information that I need. I've got some times here now. So it took 50 seconds for this bit and 350 seconds for the other bit. So so the average speed. So it's just the total distance. So I do, if you think about what I do 500 metres from my house to the post office. Then I ride back past my house. So that's another 500 metres going from the post box to my house. And then I ride another 3,000 metres going from my house to college. And think about the time it's taken me to do that. Hang on, have they made a mistake here? Right, I think there's a mistake on this, but never mind. Right then, so, oh, hang on. That's for 100 seconds there. There. Right, so time from house to post box is 50 seconds. Stand there for 10 seconds and do it. Then time from post box back past the house is 50. And then from the house to college is 300, not 350. They'd club together in the completed pack, the post box back to college. So if you work that out, it's going to be what? 4,000 over 410, which is 9.76 meters per second. Now that's not bothered about the direction. Right. Let's have a look at the velocity now. So in terms of the velocity, if you think from the house, I'm 3,000 metres away by the time I've got to the college. So I'm not bothered about going to the post office and back, to the post box. I'm just looking at that physical distance from the house to college, and it's minus 3,000. So I could have looked at it as a plus 500, then a minus 500, then a minus 3,000. Taking the positive as going from the house to the post box. And that's divided by my total time, my 410 seconds there. So my average velocity is about -7 meters per second there. So there's a big difference between speed and velocity. So you've got to be careful for that. Now it mentions on the next page acceleration as a change in velocity with time. Now it says that you've got negative acceleration, it's called deceleration or retardation. To be fair, that word has never ever come up in the paper, and I find it massively offensive. So some questions there that we'll try and work through in class. I'm going to stop there and we'll do the next bit. It didn't seem that much there, to be honest. Right, so I'm going to go on.